All right, everybody, here is our, I guess this would be our fourth question on our exam, or on the practice exam. And I've had to make some adjustments to the answer options that I gave on your form. So I hope that you have the most recent document or the most recent file. At any rate, I have some corrections and that will help out whenever you're working through this. Point is, though, this question tells us quite a bit of information immediately. It tells us that we're dealing with a second order reaction. We have a rate constant that's provided for us. Little hint, this right here, it tells us our rate constant values or our rate constant units. This is something that we could use for other questions. So if another question says, what are the units for the rate constant? Well, heck, this provides them right here. This tells us our rate constant is 0.8 molar per second, or 0.8 molar inverse seconds at 11 degrees Celsius. Here's our reaction: 2 moles of NOBr to 2 moles of NO to and 1 mole of Br2. If the initial concentration of NOBr is 0.440, the concentration of NOBr at 10 seconds is what? So this is asking us about, over the course of time, how does our concentration change? And so effectively, the best way to approach this, or the most direct way to approach this, is to do the integrated rate law equation. The integrated rate law equation for a second order reaction is 1 over A. Actually, I'm going to go ahead and use R NOBr. So 1 over NOBr is equal to KT plus 1 over NOBr sub 0, so our initial concentration. So basically this tells us what is 1 over our concentration at a time. Well, it's equal to our rate constant times that time plus 1 over our initial concentration. Well, the great thing about this is we have almost all of these values, so it's going to be pretty easy to plug this one in. So what I'm going to do is I'm going to say, well, my K value is 0.80. My time is 10 seconds. My initial concentration is 1 over, or my initial concentration is 0.440, so I'm going to say 1 over 0.440. That is all equal to 1 over the concentration of NOBr, and that's the concentration at 10 seconds. So the first thing that I'm going to do is I'm going to say 0.80 times 10 is 8, plus 1 divided by 0.440 equals 2.273. So that leads me to 1 over NOBr is equal to 10.273. Therefore, I can land at concentration of NOBr after I do the algebra is equal to 1 over 10.273, which is equal to 0.0973. Now the best answer option that I've got is answer option A. Okay. Now, I hope that was helpful, and I'll see you on the next question.